Thank you so much for joining. This is my second talk about the topic, so be kind. My name is Walmyr Carvalho. I am part of the Android engineer team at Walmyr. We do electric bikes, as you can see, which is kind of nice because most of us do only apps with screens and this kind of different screens. So this is kind of like a external factor to be contributing to the excitement of the app. So yeah, today I'm gonna talk about how you can actually do things like this. How can your app interact with this kind of devices? That's my main goal here. I have two microphones. What for? Yeah. So connected devices are everywhere, right? We have plenty of different devices. I think everybody here has a smartphone or a smart headphone or some sort of health tracker, even smart scales or the new Pixel Watch. Who has the new Pixel Watch already? Ooh, nice. 3, 4, 5. I want one. Yeah, it's kind of cool because most of these devices are on our daily lives, but we don't actually think about it too much. We just tap the phone, do some stuff, and make it work. But how it works exactly, how it's supposed to work. So that's my goal today. Just explain a bit how it works. You probably know as a developer that Bluetooth, but in general, explain a bit how the internals of the Bluetooth works and how you can actually do it yourself if you want to connect with the device. That's my goal. I'm also a beginner cyclist, so I have a lot of this kind of smart devices with me as well as a cyclist. So you see they have this kind of smart shifters without cables, wireless stuff. They also have this kind of cool devices like the Beeline Velo, which is kind of a navigator, so you can actually pair with your phone and don't need to take your phone off too much to see the route, so it's kind of cool. If there's any Beeline developer here, I love the product. This is not a sponsor message, but it's a really cool device. It's actually safer to ride with this device instead of just checking your phone here and there, so it's kind of nice. So yeah, and this is my commuter bike actually, the Walmyr S3. I'm from Amsterdam. I'm living in Amsterdam now, so this is a borrowed bike from the Walmyr store in London. I actually rode today morning from the store to here was kind of a challenge because the different way of riding on the left was oh shit, I'm gonna die. So this was really cool. So as you can see, seems like a regular bike, but the main part is it's a smart bike. So the main features of Walmyr in general are you have this kind of way of unlocking the bike with your phone, which is kind of nice. I'm gonna demonstrate that. First, let me just lock it. So it's locked. So you have this kind of different ways of interacting with the bike. So you have this kind of touch unlock, which is press the button on the app, and then you can unlock it. You have this kind of assistant level, so you can change how strong the bike helps you with the powering stuff. You can change the gear shifting moments. For example, if I want to shift earlier or later during my pedal, that's kind of cool. You can actually update your bike through the phone, so you can actually download stuff to the bike through the phone, for the bike through the phone, which is kind of cool. You pair it with the phone and then get firmware updates. Any kind of fixes, for example, wow, we have this kind of bug that makes the bike drain more battery, so we can actually fix it because here you have kind of a computer on the main tube and the battery on the low one, so it's like a computer cycle with wheels. That's exactly. So, and also you can actually change silly stuff sounds, this kind of options of the unlocking sound. Anyway, this kind of things. Let me just demonstrate a bit. I'll just switch to the here, and this is my phone. So this is the app. Let me just put it on the so many things. Yes. Yep. Yeah, so this is the app. So regular app, so you can see you have this kind of dashboard with the speed, have the battery, have this kind of way of checking the rides as well, which is kind of nice. When you ride it, and then you see how many kilometers you did, how was the battery. But the best part for me is this, you have this kind of bike, and you can actually change stuff on the bike. So you're gonna see you're gonna hear a click every time that I change stuff. You see? So what I'm doing this is I have the bike connected through Bluetooth, I'm gonna explain later how it does, but have the bike connected through Bluetooth, and then you can actually change like the light system if I want to change like to on. Let's see. Even like this kind of like the horn sound, if you can change it, you can change to a silly one like this. Oops. And you see, it's so silly that the bike thinks you are stealing it. So something that's really cool is like this when you have the 1 second. So the bike has also a way to unlock itself. So if I just do it like this, ooh, if I do this touch unlock, should work. No. Anyway, if you do like this, you can actually change unlock the bike through some commands. So it kind of gets unlocked. So the bike is intelligent, like some sort of intelligence, which is mostly like software. There's a software on the app. There's a software inside the bike. So have this two softwares talking to each other through Bluetooth. Okay, let me just go back to the slides. Looks cool, right? Yeah, so like many of these devices, this connects like through Bluetooth, but how is it done exactly? How can you actually do this? Like code speaking, like how can we implement it? Something like that. So yeah, just a single like overview of how we do it. In general, like there's different ways you pair your phone with stuff. For example, when you do like headphone stuff, you just have this kind of pairing request and then it's done. There's no security. For example, another person can actually pair with your phone, and that's okay. But for this bike, like there's a lot of security involved. Like you cannot like leave the bike around and everybody can just pick up the phone and pair it. So here just like a really basic schematics of how it works. So we have this user which has probably a bike, and we need this kind of authentication server to make sure that the bike is your bike, because you have plenty of users. Also, one thing that I'm talking about this bike, but can be related to any device. So a device can have multiple users, multiple roles. Maybe a person that fixes the bikes have this kind of role. We have, for example, something called bike doctors. So bike doctors can actually make the bike their own and then fix the bike and then give it back to you. So we have this kind of roles for the owners of the bike. So when you want to know if the bike is yours, it's just like make a simple request to get some sort of certificate to make sure that, okay, this bike is mine, I can prove it, this is my certificate. And then we have this kind of system that connects users, and it's kind of some sort of back office or some sort of system that connects users and bikes. So it's kind of like a device management system inside the cloud and the API for that. And then they say, okay, the bike is yours, this is confirmed, so you have the account and the bike is yours. And then we attach this authorization to the Bluetooth itself. So we need software inside the bike, and also we need software inside the app to make sure that you're getting the proper connectivity, you're getting also the right to connect, and you're getting also the proper keys to it. So it's like kind of a 3 steps to it. Is that clear? Okay. So that's the basics that I like. I'm not showing like specific code for that because it's a bit private stuff, but in general, I'm gonna explain like how we do it in terms of like getting the data from Bluetooth and just doing like this kind of commands that I did, like the light ones, the lock ones, how you do it. Some of these concepts that I'm saying, like this kind of like way of interacting with the device, etc., are applicable to other devices as well. So that's the concepts are transferable. But okay, but how we do it? So in terms of Bluetooth, it's kind of a easy way to do it. So you can actually define these permissions. For Android 12 devices and up, there's a way to declare permissions without getting location permissions, because one of the issues with Bluetooth in the past is it requires a lot of permissions regarding location. It's something that we're aiming to improve on our app as well, like improving the way we interact with Bluetooth like each day. So regularly, this is the way. You can actually define this kind of permissions like for legacy devices, and then in the new way, you can actually check this kind of never location stuff. So you can actually put this kind of users permissions flag and never location. that means that I'm not checking for the location for the user because it's a privacy matter. I don't want to connect to the device just to make sure that the user is there. I don't want that. I want to make my app like as blind as possible in that matter. Okay. And then if you need devices that are already paired, which is not the case here, or just not pairing this bike, it's just like connecting to the bike through characteristics of Bluetooth. If you want to, you can just use this kind of like connectivity and also the connect one and also the find location. But this last one is like only if really needed, like for a factory device or something like really specific. But I don't recommend it. For Android 12 and up, you have this kind of way of getting permissions like through Nearby. I'm going to explain a bit more about Nearby API. Nearby, it's a solution by Google that you can actually connect to like devices close by, but without the location permission. They actually use Bluetooth and Wi-Fi to make the connectivity like triangulation or something like that internally. So it makes it a bit better and more privacy concerned to get the Bluetooth permission. So it's we're in a good state, I guess. Yes, so once you get the permission for Bluetooth, the first thing you do, we're just talking about like Bluetooth low energy here, right? Just like there's a regular Bluetooth and there's Bluetooth low energy. But for this kind of case, like we need to use low energy because even low energy already takes a lot of battery. So in general, you need to make sure that you're using low energy. So here you have this kind of Bluetooth manager, which is attached to the system. So it's kind of a system-based manager for Bluetooth. So every kind of device that you want to connect and you want to interact with needs to pass through this. So if you get this kind of adapter and the Bluetooth manager and the adapter is null, it means that the device doesn't have Bluetooth, which is kind of rare today, but can happen. And in general, if you have Bluetooth adapter, so you can actually create this kind of intent to make sure that the Bluetooth is enabled. Otherwise, you cannot do anything without Bluetooth. So I'm going to explain later why this is challenging, but in general, like you need to make sure that the permission is up and the Bluetooth is enabled like on the device itself, the antenna. So when you do this, you have this kind of request, like, okay, this app wants to request your Bluetooth, and you just allow it or deny. And then if you don't allow it, you don't have like this adapter is enabled, it's gonna be false because you don't have Bluetooth. So this is clear. And then in order to find devices, you need to have some sort of scanner for them. So in this way, you have the Bluetooth adapter that comes with like a Bluetooth LE scanner. And then this is just a silly code. This is from the documentation. I'm not doing anything fancy here, just to demonstrate the topics and the concepts. So here you have the scan, and then you can actually start scan with this kind of callback. So the goal here is to actually bring Bluetooth devices available around. So not only your app needs to make stuff to make sure that the device is findable, but also the Bluetooth device itself needs to be discoverable. Not only like headphones, like mouse pads, etc., but also like this bike. This bike has a custom firmware, so it needs to make sure that on the bike side, it has the proper implementation to make the device discoverable. So I'm not talking about the device implementation because I'm not a firmware engineer, which is super tricky. But in general, you need to make sure that the device has a proper SDK or something that provides the availability, both through discoverability, the regular one, or also through pairing, which is the pairing in Bluetooth is more like a security measurement. So you can actually double the security. So my device is only paired with that device. So this is also possible. But in this case, like it's a simple code. You can actually what we do, for example, to make sure that this discoverability keeps running, we just attach this to a service. So it can be like we can start foreground, start background service. You can actually make sure that you can actually keep searching for devices if needed. For example, we have this kind of bike registration flow. When you have your new bike, you need to register your bike. So to make sure that you're finding your bike around, you need to actually start a service and then just like search for it. Even if the device sleeps and go back, like if someone calls or something, you need to keep searching for the bike. So this is kind of a good example of it. So you can just put this start scan inside a service and then call it in foreground or background. And then once you have this kind of adapter list, you just need to wait for the callback from the scanner. So this is the scanner, this one. You can just start scanning. And then you can attach this kind of low energy callback. And here you have this kind of, on the callback, you can actually list the device. Can be a recycle view list or whatever, just list the device. And then once you have the device, you have all the characteristics of it. The characteristics, Bluetooth in general has a lot of different concepts, so I'm not like deep diving too much on it. I'm recommending more content about it that's gonna happen tomorrow, but later. In general, my goal here is just explain like briefly how the discoverability works. And here we have this kind of device connect get. In general, the way we talk to the bike or any other device is like reading and writing characteristics. So for example, on the firmware of the bike can actually send stuff to the app through this get characteristic. So you can actually understand if the light is on, light is off. They have this kind of like UID serial numbers, and you can actually interact with it. And then you can see, okay, the light is on, or the light is off. Or maybe if you want to put another layer of communication on top of that, and just like, for example, some people put like some obfuscation on top of the characteristics. So if anybody actually hijacked the pairing, the data is not visible because it's encrypted. So that thing that I mentioned before about the key, you can actually pair with the encryption, like the decryption of the data. So nobody can actually, even if the person connects to the bike, the person cannot read it without the proper authorization key, you know? And here you can actually read stuff, read characteristics, and write characteristics. So when I did the whole like lights commands thing here, so for example, if I just try to do stuff here. If I do some stuff on the bike, like if I change some commands like this, I'm actually reading the current state of the characteristics and also writing different stuff on top of it if I need it. So for example, like we have this kind of gear settings for like hilly sessions, for flat sessions. So if I change some stuff, I can actually overwriting it. For example, even if I do like, I'll tap like really quickly here, like, you see like, even if I do like many comments, it kind of like have this way of queuing them in a way that's easy for the bike to, okay, I'm not like busy with so many commands. It's like we can actually have a system to organize the commands in a way that's more efficient, for example. So I remember one of the improvements that we did, like the bike, when you connect to the bike, you receive a lot of characteristics, right? Have the lights, have the power, have the gears, etc. And then one thing that was taking a bit longer was to unlock the bike. What we did was mostly like reorganizing the characteristics in a way that was more efficient to unlock first. Because for the user, it's priority to unlock, and then the user is going to think about like making the lights brighter, etc. So this is just a simple way to show it. So yeah, you think, okay, this is kind of cool, like, and then I did my app, and then everything works, right? So it should work, right? Not much. Yeah, after working 2 years with Bluetooth, my friend Marco works with me as well at Walmyr, and Bluetooth is tricky. That's the TLDR. Bluetooth is tricky. There's a lot of concepts that I need to grasp. Like, I'm still learning. Like even today, I'm still learning a lot of stuff with the firmware team, with other colleagues from the team as well. So we have this kind of service concept, the GET, their characteristics, the advertising, the pairing. So Bluetooth has a lot of concepts. You don't actually need all of them. You need mostly like some of them. So this is good because I don't need to actually be a Bluetooth expert to make a device like this, like to make my app talk to a device like this, which is kind of cool. Also, one thing that happens a lot is the difference across like OEM. So my Pixel works super differently from a Xiaomi device or from a OnePlus device, because OEMs can change how the Bluetooth stack works inside the system. For example, some OnePlus devices, they have this way of like killing any kind of service that's running in background to preserve battery. So this sucks because for us, sometimes we get this kind of OnePlus review saying, okay, my phone doesn't connect. And probably the device is on this kind of like low power mode that is cutting anything that's trying to connect like on background. And this is a challenge for us because we need to not only make the user happy, but also bypass and makes the app more reliable in those scenarios. We also don't want to make the app like running in background forever because we know that it kills the battery of the device, so we don't want that. So it's a big challenge to make the bike works in a way that when I take my phone off, the bike is there, I just press a button and I can unlock it. you can actually experience some sort of false negatives on Bluetooth as well, like especially regarding like the characteristics, the order of them. Now we're doing for example, now we're releasing a new bike, the S5 and the A5, and I was discussing with Marco this week that sometimes like it's so challenging, like so you make even the order of the reading changes if you don't have a good integration with the firmware. So sometimes you need to make sure that the SDK or the device that you're working has a proper way to read those characteristics. Otherwise, it's a bit tricky. So if you're planning to work with Bluetooth someday, just be aware. The thing that I did with the whole like tapping many commands here, you see, this kind of queuing of the get characteristics can be also tricky. So make sure to have a system. I'll mention that there are some libraries that can help on that, but we did our own implementation of that, this kind of command queuer. So we actually don't miss any kind of command. If you tap like 100 times, it's actually queuing them to run it on the bike, if it's connected, of course. Yeah, the connectivity is always a ghost like flying around. Sometimes you have the perfect scenario, like the device is like here, and it doesn't work, like you don't know why. And you need to make sure that you read like HCI logs. You can actually dive way deeper than needed to make sure that the connectivity is working as intended. And most of the teams that I talk about, like other companies, other devices, manufacturers, they have custom implementation. So you're probably gonna have your custom implementation of it. So yeah. So yeah, quite a lot, right? Is there any library to help on that? Like, is there any way to make it better, make it easier? Because that code I show, like it's big chunks of code, like too many callbacks, etc. So yeah, there's a lot of, not a lot, but like at least 2 or 3 good libraries that we can use. This is one that we use at the Move called RX Android BLE. It's mostly like a wrapper around the BLE stack, which is good because there's a lot of callbacks, a lot of stuff that you need to understand. So this kind of make, like, if you use RX Java and use like observable, this kind of like reactive programming in your project, you can actually use that. For example, you have this kind of observables and handy classes to device scanning. So it's way easier to deal with this kind of problems. So for example, connectivity can be a stream of data. So if I have this kind of observable that emits the characteristics for me, that's perfect. You can actually, if you want, you can just like get the proper API and just wrap an observable around it, a completable or something. But in general, it's really there's a good way to already use this, you know, and get some good results. Also, this kind of operations that write and read it can be single completables. There's a good integration with Timber, so if you want to have these better logs for your app, this also provides some APIs for those, which is kind of cool. And we're using production, at least a tiny bit of it. Yeah, if you're on the Kotlin coroutines first approach, there's also this library called Cable, which is made by the guys from Juul Labs, the smoking device. Not promoting smoking here, please. Just promoting the library. So it's good because they have proper DSLs for scanning, filtering, and connectivity to devices, which is good because it's focused on BLE devices. Also, it's KMM ready, so we have seen a lot of like KMM talks here. So if you want to use that, for example, to a device that runs in the desktop, for example, you can actually do it. And also for mobile or anything. I mentioned that the JS support here because it supports the Kotlin JS thing. This is kind of nice, the custom processor, because you can actually intercept the data. The thing that I mentioned about the security, for example, if I want to get the data, if I want to send the data to the bike and get the characteristics and I put some encryption on top of it, I can do it. Like this makes it easier to intercept the data and just send data to it, like in encrypted way, or maybe put some other payload to it. It also depends on how the firmware receives that, but in general, like you can use this library for that. Okay. Okay, let's see if it's good. Okay. Yeah, it looks hard. Even with the libraries, it looks really hard, but the good news is Google is listening. Like they're actually listening to the feedbacks. I'm gonna promote another talk that's gonna happen tomorrow by Eric, but people complain about Bluetooth. That's what I mean. Like people complain, Google is listening. Actually, one of the things that Google is improving is the way to pair with the device. So there's something called companion device pairing, which is the promoted way, the recommended way to do the first interaction with Bluetooth. it's like a better proposed version like approach to deal with it. But the difference is like not only it's not used as only Bluetooth but also Wi-Fi internally. So this is the thing I would recommend first if you want to try it, because it's the standard. Also improve the discoverability of it. So you don't, if you have a bad Bluetooth antenna or something, the Wi-Fi antenna might cover it to make it more available. So that's a good thing. Available on Android 8 and up, which is good because a lot of devices are already supporting like the top-notch Android versions. There's something called Nearby / Fast Pair that I'll be explaining later, but it's a good way to improve the out-of-the-box experience. Do you know those, when you open the AirPods, you have this kind of pop-up on the phone that, okay, this is your AirPods, just tap to connect. We have the similar thing on Android, which is the Fast Pair. And the main point here is you can actually find devices without asking for the location permission, which is the big like reason why this is made, like to avoid asking for the permission of the location of the user. Yeah. So if you want to use the companion pairing in general, they have different kind of filters. So for example, you can actually use this kind of Bluetooth device filter, but if you want, you can actually filter devices by Wi-Fi, for example. I have a smart trainer at home. You can actually plug your bike to train your bike at home. And they have a new device that works both with Bluetooth and Wi-Fi. So this is a case that people are already doing this kind of devices with different versions of it, because Wi-Fi is traditionally a stronger antenna. So if you have the device that supports both Wi-Fi and Bluetooth, the companion device manager approach is way better. So this, you can actually find, for example, if you want to search, make a filter and then search for a specific prefix or suffix. For example, all my bikes start with Vamove dash something. I can actually search only for those devices. It's funny because when we try to find a bike at Vamove, they have like hundreds of bikes at the office. So sometimes we need to make like custom filters to make sure that we find the proper bike. So we can filter by the name, by the ID, by the main serial. So it's up to you, but you can filter by anything. And actually, if you add this kind of a service ID, which is like every Bluetooth device is supposed to have some sort of the service ID, so it's a kind of the personal ID of each device. So it's a good way to also set a proper findable ID to match to the bike. And then once you have this kind of like setup, you do some sort of pairing request. Adding the kind of filter, so I set the filter inside the request, so I only doing the request for those kind of devices, which is logical. And then if you want to, okay, I want to stop the connectivity and the scanning. If I find that specific device, I can just set this kind of flag as true. This one, set single device true, and distribute it. And then you also have this kind of callback from companion device manager callback, that if you have a device and then you're gonna get this kind of pop-up, that's that one that I showed here. You have this pop-up full of devices. When you listed them, you're just gonna pop up here, plenty of devices. So yeah, this runs in kind of like system service context. So if the app is running on the application context, you can get this kind of information from any place of the app. That's what I mean. And then here, when you have the device, when you start the activity result, that intent, and you select one on that list, you get the device here. So which means that you can actually interact with the device like we did before with the get. So that's kind of clear. Okay, looks good. And I know it's a lot of code, a lot of stuff for a simple thing, which is connecting to the device. But that's why I mentioned that Bluetooth, Google is listening, and they are aiming to improve and hear the community to make the APIs better for it. So the CDM is a recommended approach for more like a private Bluetooth connection, which is good. But in general, like, you can actually do the connectivity with or without the pairing. So it's up to you. So if you want to do more like a secure connection, in matter like on the device side, on the app side, it's good to have the pairing. But if you don't have it, it's all good. You can actually provide security in different ways, like the schematic thing that I mentioned about the security. You can actually put your custom auth key on top of it, and that's it. Another good thing that happened recently, I think end of last year, mid this year, is Bluetooth is now inside Android X. which means that it's supposed to run faster. The improvements and the feedback loop should be a bit faster now. So if you work with Bluetooth and has something to report, it should be faster now, because now Android X is the way that Google made to like improve APIs in general. So not only for Jetpack but also for any kind of API. So this might be a good thing for the future of the Bluetooth APIs. So I'm hopeful actually. Another good thing that happened is like now you have emulated Bluetooth. So from the Android emulator 31.3.8, it was announced on this Google I/O. You have a way to simulate the pairing through like virtual Bluetooth, which is kind of cool, because not everybody, especially now this kind of Android dev that has iPhone type of people, you don't have Android devices around that often. So it's good to have like virtual Bluetooth devices to try out stuff, because the implementation should be the same. You don't need to actual device to try Bluetooth. So this also improves not only the connectivity testing, but also the integration tests. So if you want to actually write tests for like pairing, you could with this. That's why you can actually put this, if you have this emulator on your CI, you can actually create a test to actually reproduce the pairing process if you want. So this is kind of cool, right? Because it's a physical process, so it's kind of nice to see like if it's virtually implemented. Oh yeah, sorry, and they're actually planning this to make like more virtual device types, like heart monitors, this kind of beacons, this kind of different devices. So I hope next version they have this kind of different ways of simulating things. Maybe I'll put a bike there. Yeah, besides BLE, because BLE is a industry standard. Every phone has Bluetooth and everybody uses Bluetooth on a regular basis. But then a different way to connect to like with Android devices, like on devices in general. There are some, but not yet super popular. The first thing that it's happening for a while now, it's like the Nearby/fast pair. Nearby is the whole like API/implementation. The fast pair is just a feature of it. So they have, do you know when you tap share on your Android device and you have this kind of nearby icon? That's the thing. Like you can actually share stuff with people close by, with devices close by. So it's the same thing. Google did something to improve the sharing, the connectivity with this kind of like close by devices. So it's important to have the Companion Device Manager, the device pairing implemented, because this is required to make fast pair works. The documentation implementation for the manufacturers is also important, because you cannot do it only on your phone. You need to actually make the firmware and the system available for fast pair. I know some companies, like some manufacturers, some semiconductor brands are already making like boards with fast pair support, which is mostly a specification. So if the board implements it, you can actually use it. So for now on, it's mostly like for headphones, but imagine like if I just get close to the bike and have this kind of, okay, your bike is here, just press a button and it's good. So this kind of, imagine like having the bike in the same context, like you just turn the bike on and you have this kind of cool pop-up improving the out-of-box experience. That's kind of cool, right? So this is probably getting more popular outside the headphone the market soon. We actually tried to see if we could make this bike you work with this. Technically, like nothing is stopping us from doing it, but we don't have the APIs yet, so that's why. And also another thing it's coming widely supported soon is the ultra wideband. Some devices are already supporting Android, like there are some boards, some manufacturers are working with it. Ultra wideband is good because it's a system that you can actually find stuff in a location, contextual location matter. For example, if my phone is like this or like this and the device is there, my phone pointing to there, the device is available. So it's kind of like movement, sensorial movement. You have this kind of sensorial movement on the device itself. So for example, the Apple Find My, the AirTags, they use this ultra wideband internally. So for iPhones, the ultra wideband is already like a popular thing. So it's good, for example, if you want to have this kind of contextual things, like to unlock cars, to try to find some product inside of a store. So even like for factories, like big shelves, like if you want to find a specific product, you can actually point your device and then you can find it. So it's a really good standard. This brand called STMode, they have these devices already available, but only with SDK for iOS. Android the support is getting there. You see, like there's some devices already supporting it, like Pixel 6, Galaxy Note 20, Galaxy S22, but the APIs are not there yet. So it's yet to come, but this should be the replacement for the BLE. Like it's good to connectivity. It's good for finding stuff. So we did some sort of POCs, like moving the phone to see if we could find my bike, and then I just get close by and the bike got unlocked. This is kind of like a cool concept to explore, for example, but can be used for many things. If I recall correctly, the Tesla cars, I think they use ultra-wideband to unlock them, but I'm not sure. So let me see if my time is correct. I think so. So to summarize, connected devices are everywhere. Like everybody has a headphone or everything, or I mean, even kind of this kind of things that I mentioned. And it's kind of cool, like, to be a developer and be interactive with this kind of device. So it's a good thing to do, because you can actually get this outside of this app-only master detail like workflow, which it's nice, but sometimes it's kind of boring. So, and also BLE is industry standard. So if you don't, we don't have many other options at the moment. But you see, like I mentioned the ultra wideband, I mentioned the fast pair. There are some things coming. Also, I was thinking about mentioning the Matter pattern for the Matter standard for the smart homes. That's also coming for the Google Home app. So, for example, if you want to scan a Matter QR code, you can actually interact with your app easily. So I might think that they're gonna release some SDKs for Android as well soon, like even like officially. So different ways of connecting are coming. And Google is definitely aware of those improvements, especially on BLE stack, because it's a bit tricky to implement. But you see, there's many libraries, many options, and you can actually interact with a lot of things, like just doing firmware and the app side. So, for example, I saw some people doing Arduino. If you want to automate your home, you can actually make a custom firmware, C++, Rust, whatever, and then you can actually implement the Bluetooth library inside the firmware, and then you can just expose those informations from the board, like lights, sensors, motors, etc. I saw a guy making like a custom control car, like tiny toy car. You can actually control through the phone, which is kind of cool. So if you want to play with it, there are plenty of content online about like Arduino, like Bluetooth implementation. So it's kind of cool. And then you can just do the Android side, which just makes you like a superpower. And fast pair is something already a reality for some products, but mostly for headphones. I hope to see more like smart devices like bikes, like heaters, etc. in the future. And the ultra wideband that I mentioned is promising to be like a good replacement for BLE, but in general it's just a promise. We don't have anything like concrete yet, but keep your eyes, keep your ears like listening, because I think it's gonna happen soon, I guess. And let me see. And that's it. Thank you so much. Just before finishing, there's some good content about BLE that I recommend. This is a talk by Eric Hellman from last year about the state of BLE in general, which is really good, from droidcon Berlin. And there's a talk in droidcon London, aka tomorrow, about the state of BLE as well. So this is kind of a good content to subscribe. And all the slides are here if you want to get these slides. And I think I have 1-2 minutes for questions if you want. Any questions? If anyone wants to check the bike as well, it's here. It's kind of cool to see the bike. Or any kind of like a test ride. I'll be around. Thank you so much.